Hello guys, this is Vishnu and my probability and statistics concept video topic is about test of significance for difference between two sample means. So let's get started. So what exactly is an hypothesis? Hypothesis is used to make decisions utilizing the data, and it's a kind of a rule that specifies whether to accept or reject a claim about a population depending on evidence provided by a sample of data. It's just kind of like predicting, but not exactly. But yeah, it's predicting. It's just like analyzing it. But hypothesis is kind of like statistical measures by comparing the data sets and the validating the data. It's nothing but the hypothesis. So let's move on. So there are two types of hypothesis, which is null hypothesis and alternative hypothesis. Null hypothesis is a measure uh, that is considered from the whole data. Like if we have 2 to 3 data sets of ABC schools on particular exam, those all marks we can calculate the average, and that's what a null hypothesis is. We are considering each and every school and each and every uh, student's marks. So and we are making an average out of it. So it can be considered as a null hypothesis. And alternative hypothesis, yeah, I will just um, um, null hypothesis is denoted by h naught, and alternative hypothesis is denoted by h1. So um, alternative hypothesis is considering a particular set of data, like considering random data from the middle of the whole data set, or portions uh, of a of random data, collecting just random data and calculating the mean or processing that data is nothing but alternative hypothesis. And we can relate it as follows. Here we can see the comparison table. Null hypothesis and alternative hypothesis. Well, null hypothesis is a statement in which there is no relationship between two variables, and alternative hypothesis is a statement in which there is some statistical significance between two measured phenomena. And in null hypothesis, no observed effect. It represents no observed effect. And alternative hypothesis, some observed effect represents. And what exactly is null hypothesis? It is what the researchers try to disprove. And alternative hypothesis is what researchers try to approve. And acceptance. No changes in options or actions in case of null hypothesis, and changes in opinions or actions in alternative hypothesis. Testing of null hypothesis is indirect and implicit, and alternative hypothesis testing is direct and explicit. Observations of null hypothesis, results of chance, and alternative hypothesis observations are the result of real effects, and denoted by h0 and h1 as we've seen earlier. And mathematical formula is null hypothesis equal sign. It's um, mu1 equals to mu2, and unequal sign mu1 is not equals to mu2. This is what unequal and equal signs are. Let's move on. So kindly, there are types of errors. There are two types of errors. So type 1 error is about risk of these two errors are inversely related, and type 2 error is determined by the level of significance of and the power phi of the test. So yeah, as you can see in the table, if h naught is true and failed to reject, I mean the researchers failed to reject the H naught, then a correct decision is a probability of 1 minus alpha. And H naught is false. It's a and fail to reject H naught. It's a type 2 error. Fail to reject H naught. When it is false, probability is beta. And H naught is true and rejected H naught, then it's a type 1 error rejecting H naught when it is true, and probability is alpha. And H naught is false and reject the H naught, then it's a correct decision. And it has 1 minus beta. So let's look at what is an alpha. Alpha is nothing but producer's risk. Producers in nothing but researchers. It's a risk of researchers, and in other terms, it's a level of significance you set for your hypothesis. And must and alpha should be of a lower value. And coming to beta, what is this beta in here? It's the consumer's risk. It depends on the power of the test. And let's see what exactly it is, what exactly these tables and these errors are telling us in next slide. So let's consider test case. Null hypothesis and alternative hypothesis have been done. So yeah, for null hypothesis, the two medications are equally effective. We are taking two drugs over here. Type this is one, this one, and this is two, and this is another one, and this is another one. So type 1 error. When does a type 1 error occur? Rejects H naught when it is true. This error is not too severe. Since these both drugs, this and this, are same, the, I mean chemical composition may be different, but the effects when a consumer or the patient um, gets him or herself into their bodies, then there will be no major effects, and this is not too severe. The patients will still benefit from the same level of effectiveness. These both, this equal to sign is not equal to sign. What it is describing is these both drugs are not equal. Not equal in composition, not equal in chemical structure or chemistry, or in chemistry, internal chemistry, they are not equal. But the patient is still benefited, and it's a type 1 error. And coming to a type 2 error, it will be of something fails to reject H naught when it should be. Let's consider these two medicines are same. These two chemical composition, the amount is each and everything is same, but it's not advised to give it to the. I mean, it's not at all related to the person's uh, medical history or I mean, the what is the medication is. It's not related to that. Let's say the patient is undergoing through some thyroid gland some problem, but he is given something related to pancreas. So there's no there is I mean there's no reason at all. I mean there is no relationship between them, and this error is life threatening, and this kind of errors are known as type 2 errors. So I guess this given whole level of understanding of what it is. And there are something like one and two sided hypothesis. One sided hypothesis is also known as directional hypothesis to determine whether the population parameter differs from the hypothesis value in a specific direction or not. We can specify the direction to be greater or less than the hypothesis value. Greater than in the sense over this region, and less than over here in this region. So more powerful than two sided. It's a more powerful than two sided, which is this one. We'll see it next. So this is two-sided hypothesis, also known as a non-directional hypothesis, to determine whether the population parameter is either greater or less than the hypothesized value, less powerful than the one-sided, where you can see this is less side and this is the greater side of the bell curve. It's inverted bell curve, or it's a bell curve. And erase. So p-value or critical value. A critical value is a point on the distribution of the test statistics under the null hypothesis that determines a set of values that self for rejecting null hypothesis. It's like um, uh, the p-value should be the smallest, uh, which results in the rejecting the sample evidence of the null hypothesis, which is h naught. H naught, the null hypothesis. The p-value should, uh, if the p-value is less, then there is a stronger chances for rejecting the sample evidence, which is nothing but the h naught. There's a very great extent of rejecting this h naught, rejecting this h naught. That's it, and it depends on the p-value. So that's it all for this PPT, and thank you.